in the last 30 years, we have very good evidence that the climate of the Earth has been warming. The temperatures of the last few years have been higher than they have ever been in the last 1,000 years, and probably higher than they have been in the last several million years. We think that this is happening because of human activity. We treated the mitigation of global warming as a problem in engineering and physical science. Up until then, the people who have been dealing with it were primarily economists and politicians. And they basically thought it was really a problem of regulation. It was a problem of passing the right laws. It was a problem of creating the right kind of treaties. And for the first time, we began to say, well, wait a minute. Even if we pass these laws, even if Kyoto were to be ratified, we still would be nowhere near able to implement even its modest requirements, and how would we ever get to the real problem?
Power consumption today is 12 terawatts, 85% fossil fueled. By 2050, the world will need 30 terawatts from a source 3 times as clean as today's power.
40% of all the people on this planet are not connected to any grid. What's going to be their power source? Are they going to build coal-fired power plants? And that will have an incredible impact on the CO2 going into the atmosphere. I mean, not to mention China and India with more than 1 billion people each. We're using fossil fuels millions of times faster than nature makes fossil fuels, and just on the face of this is really not sustainable.
For 4 billion years, the sun has laid down a deposit of fossil fuels. In a little over 100 years, we have used up nearly half. One way or another, the 21st century is the last one to use fossil fuels.
Our civilization runs on energy, and as those energy sources become rarer, so will it become more difficult to run our civilization. Right now, if we just keep doing what we're doing, the lights go out in a few hundred years.
Each person in the developed nations uses far more wealth and energy than we imagine. Every possession we own was created by a vast complex of processes, each with an energy bill of its own. When we turn on a light bulb, we see the energy created by a power plant miles away and sent down the circuit. What we don't notice is the energy used to mine and refine the silicon and transport it. We don't notice the energy cost to build the power plants, manufacture and string cables, or the energy needed to build the roads, design and manufacture the trucks and equipment for the crews to maintain them, or the enormous energy capital required to support and educate all the people who build and maintain the infrastructure. We don't notice the human wealth necessary to build a society, to support universities where scientists create that technological infrastructure. Developing nations lack this investment. They get energy directly from the biosphere. These resources are already severely stressed and will become critical as population doubles. An advanced economy can provide its population with 6 kilowatts per person. People in developing nations average 1/10 of a kilowatt. Over 4 billion people use only 1/5 of a kilowatt per person, while large numbers have no access to electric power at all. Providing 10 billion people with energy is something conventional systems cannot do.
None of the existing alternate energy studies at their present state of development was technologically ready to provide the power that we're going to need.
Solar power and wind are intermittent, too expensive to collect, store, and distribute. Biomass is limited. Photosynthesis has very low efficiency, 1 to 2%. To get 10 terawatts from biomass would require 10% of our total land surface, an amount equal to all present agriculture. Getting 10 terawatts from solar cells would require an array of 220,000 square kilometers. Renewables suffer from low density. They aren't where you need them in concentration. Fuel cells are up to 40% efficient and run on hydrogen. But making hydrogen uses more fossil fuel for power than burning the fossil fuel itself. Even doubling efficiency, we will be overwhelmed when China and India follow the path from bicycles and mass transport to cars. Asia already accounts for 80% of petrol consumption growth.
It became very clear that the limiting of CO2 emissions would require a transformation of the global energy system. We would need to somehow generate between 100 and 300% of all the energy that people consume right now from a source that didn't emit CO2 into the atmosphere, between 20 and 60 times as much energy that we're going to need from some source, let's call it source X, in 50 years. That's an unprecedented technical challenge.
There are no earthly technologies now online or capable of coming online by 2050 that can solve the world energy problem.